Hello everybody, welcome to your 6-3 lesson on exponential growth and decay. Our learning target for this lesson, we will use exponential functions to model situations and make predictions. We will be able to construct exponential growth and decay functions given a description of a relationship, and we will be able to recognize if a situation can be modeled with exponential growth or exponential decay and interpret the parameters of the model in context. All right, so you can see we have some vocab to put in our notes, so let's get started on that. First, we have compound interest. That is interest that is paid on the principal investment or deposit and on the interest that has already been paid. The compound interest formula is an exponential growth function. So the formula itself is going to be a video later in this lesson, but that's what compound interest is. Decay factor, I'm going to write this one in. That is 1 minus the decay rate. Which we use an R to represent the decay rate, and that's going to be 1 minus R. All right, exponential decay. So we know that exponential functions can be written f of x equals a times b to the x. For it to be an exponential decay, our a value will be greater than 0, and our b value is going to be between 0 and 1. So when our a value is greater than 0 and the b value is between 0 and 1, that's going to be exponential decay. And we can write our function specifically for decay. So a times 1 minus r raised to the x power, and r is the rate of decay. That's going to be a percent value that we will turn into a decimal. All right, so decay factor was 1 minus the decay rate. Growth factor is going to be 1 plus the growth rate. And the growth rate is an R as well, so it's going to be 1 plus R. That is the growth factor. All right, so exponential growth, it is an exponential function, so similar to what we said above, exponential functions are f of x equals a times b to the x. If it's an exponential growth, our a value will be greater than 0, but our b value is going to be not greater than 0, greater than 1. So if this b value right here, the one with the exponent, is greater than 1, then this is an exponential growth, and we can write a more specific function for the growth. So f of x equals a times 1 plus r raised to the x power, and r is the rate of growth. All right, so let's take a look at some examples.